Okay, at the first step, let's go to the source code. Okay, this one. Copy them all. I don't see. And then go to the Arduino IDE and click the menu New. And after that, pass the code. Control V. Okay. Next, try to compile it. Okay, it will ask to name the project. I will name it example ESP32 made using the ESP now. Enter. Okay. Okay. Let's wait. Okay, we found the first error now. It is the LED built-in was not declared in this scope. Okay, let's fix this error by go to define LED built-in. Let's say the pin number 2. This lines will be compiled at the compile time of the Arduino IDE. The number 2 means the pin GPIO. It depends on your board. When I use the ESP32 board, the built-in LED uses GPIO number 2. So I define it here. Next, compile again. Okay, we found the second error here. This line. Okay, we need to define the correct function to be the callback function when data is received. This line use the old style attach of the callback function. We need to update to the new one. So let's go to this one. For the new library, the new version, you need to use this function. Okay, let's compile again. Okay, the next error is this line. It used the old parameter, so let's use a new one. When we initialize the ESP or add a new node. Okay, this one, copy and pass. Okay, let's compile again. Okay, there's no any more error now. For the comparison of the code, but one line that I found some error is when we add a new peer to the network, we need to fix some error. Let's see. Add the peer. Okay, this line. You need to fix this one. Okay. This function when the node in the network broadcasts a data by sending the MAC address, it will check the data type and then check the MAC address. If the MAC address is the new one that have not yet been added to the list of the known device, the receive data will try to add a peer using the MAC address, this line. Okay, let's compile it. Okay, there is no error now. We are about to program this code to the board. When we program the board, we need to change this parameter myID. In this example, I have 3 boards, 2 ESP32 boards and 1 ESP8266. So there are 3 boards. The first board, I will number it the number 1. Okay, and let's check a little bit more. If in the loop, after the initialization of the network, it will broadcast its IP address, so the other node can sense that this device exists, and the other node can add this board to be the new peer. And you can also send the command to the network as well. For the format of the command, you can see in the website, this website. Okay, it describes how to run the code. The example command is like the one and on. To turn on the LED on the device with my ID is equal to number 2. Okay, let's try to program to the board. Okay, now I have prepared 3 boards. You can see that I have the ESP32 VMOS board, and this one is the ESP32 with the external antenna, and this one is the ESP8266 or the node MCU. Okay, next I will try to program the VMOS board first. Now we go back to the Arduino IDE with our example of the ESP32 mesh using the ESP NOW library. For the VMOS board, I will define it as the board ID number 1. Okay, and then I will plug the USB cable for now we don't port number 10, maybe when I plug the USB cable. Okay, the VMOS board power on, and the port that we get is the port number 12. Okay, select the port number 12 and start the program. Okay, it's finished. Compile the source code and it starts. Program the board. Okay, finish. Let's check the serial monitor. Okay, now the VMOS board. The board ID number 1. Try to broadcast its MAC address, but now there is no any receiver for such broadcast message. So okay, I will close this serial monitor and I will use the PuTTY program to monitor the serial of the VMOS board. Let me open the PuTTY program. Okay, PuTTY program. We will open the serial port. The number is 12. The baud rate that we use is in this number 115200. 115200. Okay, open. Okay. It seems that when we open the serial port by using the PuTTY, it reset the board. And because we can now the message ESP now in success, it is the start of the program. Okay, next, that's not the problem. Next, we will program the ESP, another ESP32. Okay, let's see. We define another board, the number 2, and then I will insert the USB cable. This one. This board. Okay, I have inserted the USB. Let's check the COM port 2, COM 9, number 9. Okay, let's select the number 9 and then download the program again. Okay, now it's starting to program the board. Okay, let's check the serial monitor. Okay, now the ESP32 board get the MAC address from the VMOS. Okay, let's check again. You can see that the COM12 open by PuTTY, I connect to the VMOS board and it receives the MAC address from the ESP32. The MAC address ends with the FC letter, this one. And for another board ESP32, the MAC address that ESP32 got is from the VMOS board. The MAC address ends with the number 78. Okay, I will try to reset both of them. Now I reset the VMOS board and then I reset the ESP32 board. Both of them can successfully initialize the ESP now. Okay, now it start to because both boards try to broadcast their MAC address. So one of them will receive the MAC address from the other. Okay, now we can successfully communicate the between two bots by using the ESP NOW library and the way that we communicate with the way that both they communicate it use the ESP-MESH architecture. Let me power off the one of them, ESP32. You can see that the this board cannot receive any more message from the other node. And then I will power on the ESP32 again. Okay, now even though the COM9 serial monitor COM9 does not display any message, but the VMOS can still uh, receive the message from the ESP32. Okay, this I simulate the situation that when one of the node in the ESP-MESH network is removed, it because we have only two nodes. So if when there is a new node come into the communication range of the mesh network, the nodes in the mesh network can still will acknowledge the new member of the node. Okay, next I will make another node by using the ESP8266. Here is the code that I prepare. ESP8266 ESP NOW match. Most of the details are the same as that I use to program the ESP32, except some functions, small detail. For, for example, okay, I change the port ID of the ESP node to the number 3. Some details are different from calling the function in the ESP32, like the ESP send. We don't check any feedback returned from calling this function, and the size of the message I think it's the same. And when okay, when add appear, this is another difference. When we use the ESP node MCU, we need to set the role of the board. But in the case of the ESP32, we don't need to set the role of the board. This is one difference. On the data received, the same as the peer. Okay, the LED built-in, it is in this code I does not define the LED built-in in this code, but it is actually defined somewhere when we compile the program. When we select the ESP32, okay, when we compile the program for this board, we need to select the board to the ESP8266 and the node MCU here. Okay. Okay, by default we use the channel 0 or the Wi-Fi communication, but remember that when we use the ESP32 library, we don't need to connect to the Wi-Fi. Please remember this point. ESP now is a low power communication approach, so we don't need to connect the Wi-Fi. But in the area, if there are several Wi-Fi networks, you may need sometime need to change the Wi-Fi channel to another channel, like the channel 1, channel 2, channel 3, and so on. Not over, I cannot remember, maybe 13 channel, the maximum. Okay, when we init the board, okay, this is another different. We need to set the low of the board. We need to set the role of the board to be master or combo, and the peer node to be slave or combo, something like that. And for the to register the receive callback, in the case of the ESP32, we need to call another function inside here. But in the case of ESP8266, we don't need to call a special function. Okay, now I think we are ready to program the board. Okay, we have select the board name, and for the port we don't know. Okay, I will insert the USB cable. Okay, what port number that we get? This source code. Okay, to select the port, I think number 11, and let's program. Start writing the code to the node MCU now. Okay, the program complete, and you can see that the VMOS board can receive another MAC address end by 77 here. This MAC address belongs to the node MCU. Okay, I will try to send some command to turn on and off the onboard LED of the node MCU, but I need to change the program to monitor the serial port. Okay, let me close this one. Okay, let me use the putty again. I will open the node MCU serial port by using putty. open. Okay, it resets the board. Okay, now next I will open the serial of the ESP board to the COM12. Open the serial monitor. Okay. Now I will try to turn on and off by sending the command. The number, if I'm correct, number 3 is the board ID of the node MCU and the on function to turn on the LED. Okay, let's enter. Yes, something happened. Okay, let's check, do it again. 3, oh, off. Okay, now the LED is turned on. In the original source code, to off the command off, it will set the logic GPIO that connected to the onboard LED to be 0, and the logic 0 will activate the onboard LED. But if we command to on, it will set the logic to 1 and it will turn off the onboard LED. Okay, let's do it again. 3 on. Now the onboard LED is turned off. Let's do it again. 3 off. Enter. Yes, it turned LED is on. And 3 off, on. It will go off. Okay. Okay, now we have successfully built the mesh network using ESP boards, two ESP32 boards and one ESP8266. Okay, thank you very much for watching this video.